All right, guys, we're going to add on to the limiting reactant and excess reactant stuff by talking about actual versus theoretical yield. Okay. Um, the theoretical yield uses math. Okay. Specifically, we use stoichiometry to find the mass. The theoretical yield you've already been doing. It's the amount that your limiting reactant gives you. Okay, so when you've been finding the maximum amount of product that can be made, you've already been finding the theoretical yield. That's the maximum amount of product that can be produced by the limiting reactant. So exactly what you've been doing when you find your limiting reactant and how much product it produces, that's your theoretical yield. So that's in theory, what you should get based on math. It's not always what happens in a laboratory setting. Okay. There's reasons for that. And you guys haven't done labs this year, and I don't know what your lab experience is for science earlier on. But when we're doing labs, especially in something like chemistry, um, stuff can get stuck to the beakers. You cannot pour in quite amount of a liquid. There's all kinds of reasons why you wouldn't get the exact mathematical amount. If it's a gas, some of it can escape. So we also have the actual yield. That's the amount that's actually produced in the experiment. That's always given to you in the problem. Okay? Because you can't know unless you do it yourself, which isn't going to happen. So they'll give that to you in the problem. The other thing you have to know is percent yield. Percent yield is the actual yield divided by the theoretical yield times 100. So I just remember percent yield is where it's at, A over T. This measures the efficiency. Obviously, if you were working in some kind of business where you're manufacturing something, and let's say it's a chemical plant or a pharmaceutical plant, or even if you're making cars, you want to have as close to 100% efficiency as you can get. That means you're not wasting any product. You don't have any excess left over. Probably won't ever happen quite like that in the real world, but you want as close to 100% efficiency as you can get. Different types of industry, have different expectations for the amount of efficiency that's logical and reasonable. But, you know, closer to 100, the better, right? So that's what the percent yield is going to tell us. It's going to measure the efficiency using the actual yield, how much you actually made, divided by how much you should have made based on the mathematics. So we're going to learn those things. Um, so I'm going to do an example with you guys. So we'll use my phone. So we're going to use the good old trusty carbon dioxide and water. It gives you glucose and oxygen example, um, photosynthesis. So if I tell you 18 grams of oxygen is produced from 20 grams of CO2 and 25 grams of H2O, what is the theoretical and the percent yield? All right, to find the theoretical yield, we do our stoichiometry. Find amount, limiting reactant produces. And that's what you guys have been doing. So we're going to do that. Let's see, I don't think I can change. Maybe I can. No. Okay. So we're starting with, now remember, this is your reactants. We're finding the limiting reactant. This right here, 18 grams of O2, O2 is a product. So we're not worried about that right now. That's going to come in later. Okay. So we are starting with 20 grams. Actually, let me do this. Okay. So we're starting with 20 grams of CO2 as one of our reactants. And we have 25 grams of H2O as our other reactant. So we're going to do our stoichiometry to find the limiting reactant. So CO2 molar mass is 44.01 grams per 1 mole of CO2. Then we're going to do our mole ratio. So we're going to have, what do we have? 6 moles of CO2 to, since O2 is mentioned in here, that's the product we're going to work with. So 6 moles of O2. I'm going to go ahead and take that out to the mass. Oops. And remember, O2 is 32 grams, because there's 2 of them. All right, and let's see how much oxygen is produced with this. So we've got 20 times 6 times 32 divided by 44.01 times 6. I get 14.54 grams. Produced from 20 grams of CO2. We got to do the same thing with H2O. Molar mass, 1 mole. Then our mole ratio, moles of H2O to moles of O2. H2O is also 6, so we've got a 6-to-6 ratio again, which is really 1-to-1. And we're going to take that out to the mass of our O2. All right, 25 times 6 times 32 divided by 18.02 times 6. And that's going to give us 44.40 grams of O2. Okay, so that means that we know our limiting reactant had to be CO2 because it gave us the least amount of product, and that is your theoretical yield. So again, it's just exactly what you've been doing. We just didn't call it that. All right, now we want to find the percent yield. Well, the percent yield, if you remember, is actual over theoretical. Over theoretical times 100, of course. So we know our theoretical yield is 14.54 grams of O2. And our actual yield, if we look here, is 18 grams of O2. Make sure I calculated that first one right. Yeah, I did. Okay, so this is normally you're not going to get over 100%, but in this case we are. So we're going to get 123% yield. So something has gone very wrong in our lab if that's the case. Normally you're going to get less than 100. It's probably because I just kind of made this up. So that's okay. So 123.8% yield tells you that's not even possible. So what must have happened is we probably spilled some extra CO2 in there when we were doing the reaction, something like that. Again, usually you'll get under 100%, but that's how we do actual theoretical and percent yields. Okay, so here is a problem. If you guys want to try to work it out on your own, that's probably a good idea. And then pause the video, work it out on your own, and then come back and I'm going to walk through it with you. So I would pause now and do it, and I'll see you in a second. All right, now that you're back, let's do this. Move this up. All right, so we've got our P4O10 plus 6H2O gives us 4H3PO4. Okay. It says 3 moles of P4O10 reacts with 9 moles of H2O. If 575 grams of H3PO4 is produced, what is the percent yield? Let's take a look and see. So we're going to start we've got to find our limiting first before we do anything else. So this is what you guys should be doing first. You've got your 3 moles of P4O10. And we've got 9 moles of H2O. Those are our reactants. All right, we're going to go ahead and convert those to grams of our product. So since we didn't start with grams, we can go right into the mole ratio. P4O10 is 1 mole. And we're going to H3PO4, so 4 moles H3PO4. And again, I'm going to go ahead and do grams because we're going to have to get there anyway. So I'll get my molar mass, so 30.97 plus 3.03 plus 64. It's going to give us 98 grams. Over my 1 mole of H3PO4. All right, that's going to be times 4 times 3. That gives me 1176. All right, now I'm going to do the same thing with my water. Oops, my bad. Ignore that for a sec. I was thinking about grams, but we're in moles. Okay, so we've got 6 moles of water to 4 moles of H3 PO4. We'll do our molar mass of H3PO4 to our 1 mole of H3PO4. And we're going to get 9 times 4 times 98 divided by 6, and this gives us 588 H3PO4. Okay, so what this means is that H2O is our limiting reactant. This is our theoretical yield. Since we have our theoretical yield in the equation, it gives us our actual yield, how much is really produced. So we're going to have 575 divided by 588 times 100. And we're going to get a 97.79% yield. That's probably a pretty good yield depending on what we've got there. Okay, so hopefully you guys got that right. If you're having any trouble with this, send me an email and I will be glad to help you. And that's about it. See you soon.